All right. Morning. Welcome to the Electricity Alternative B Waec for 2024 session. It's a practical demonstration for Alternative B, Electricity Practical, Waec 2024 Alternative B, and this is my prediction. This is a cell of EMF, the key, all in series, the ammeter in series to the resistor in series, but the resistor will be in parallel to the voltmeter. That is circuit diagram. That's the question. Set up as shown above with E 1.5 volts. So the first cell will be in 1.5 volts. Close the key, take the reading of the ammeter as V, take and record the corresponding reading on the ammeter as I, and take and record the reading on the voltmeter as V. Then evaluate for V inverse, in volt inverse, and current inverse in ampere inverse. Then you repeat for 4 other values of a cell having an EMF 3 volts, so you double the cell. 4.5 volts, make it 3 cells. 6 volts, that's battery of 4. Then 7.5, battery of 5. So altogether, each of 1.5 volts. I've also inputted the table, the nature of table of values. Volts in voltage, current in ampere, volt inverse in volt inverse, voltage inverse in volt inverse, current inverse in ampere inverse. All readings will be in 3 decimal places. My handle, YouTube handle is over there at Peter Amechi 2028. PITAAMAECHI 2028. You have to plot a graph of V inverse on the vertical axis against I inverse on the horizontal axis. The first parameter mentioned will always be on the vertical axis. The second is on the horizontal axis, except otherwise stated. This practical, the graph will have an intercept. It's expected that you have an intercept at E on the vertical axis. The intercept is E. It's denoted with letter E, and it is to be on the vertical axis, not on the horizontal. You distinguish your axis, find your slope, change in V inverse against change in I inverse. Write the nature of how the graph will be when plotted. Determine the slope, determine the intercept. State 2 precautions. I ensure I avoided error due to parallax while taking reading from the voltmeter. Another person can say I avoided error due to parallax while taking reading from the ammeter. I ensured tight connections. I avoided reverse biasing by connecting the terminals appropriately. How do you state 2 methods of production of electricity production? 1, by the use of solar cells. 2, by the use of hydropower electricity generation. Look at this big question, BII. The effective resistance is given as 4 ohms. Then we are looking for the value of R. You calculate the resistors in parallel first, find the total resistance. You add it to the one of 2 ohms, then you equate it to 4 ohms, which was the total effective resistance given by the examiner. My name is Amechi Peter. You can also watch the other clip on optics for alternative B and magnets on the same handle. If there is any need for any question, drop your question there. So let's go over as we set up the apparatus. Okay, here we are. So as seen on that diagram, circuit diagram, this is the ammeter, The ammeter is a dual ammeter, 3 ampere and 5 ampere. So I connected with the 5 ampere. That means I'm going to be making use of the downward reading, not the upper one. If you connect to 3 ampere, you make use of the upper reading. So this is the ammeter. The ammeter is connected in series to the key. The key is connected in series to the cell. So the one we are going to start with will be the one of 1 ohm, 1.5 volts. First cell before we go to 2, 3, 4, 5. Then there is a junction from the resistor. This is the voltmeter connected in series to the 2 ohm resistor. Then the junction from the terminal of the resistor. From the junction, you can see the junction here. You now connect to the cell and connect the other. From that junction, you connect back to the ammeter. So that is how the connection is made. It's a very simple setup for electricity alternative B. So we start. We are starting with E 1.5 volts. E 1.5 volts. So we use a cell, connect the battery, connect the battery. You can use a battery rack, connect the battery. If you notice reverse biasing, what the pointer of the ammeter, if they are going backwards this way, that reverse biasing, you change. If you connected positive and negative, you revert it. Then if you do that, the reverse biasing corrects itself. So with that, I have a reading. I've connected the cell. The key is closed. I have a reading on the voltmeter. What's my reading? I'm using the downward reading, so 0.25. Then on the voltmeter, I have a corresponding reading. I have a corresponding reading as 0.7, 0.7, 0.65, 0.25, 0.65. So I'll go to my table of values. 0.65, 0.25 for current, voltage 0.65. The reciprocal, take the value into decimal placement accordingly. Then I proceed to the second one. The second one, the EMF now changes to 3 volts. So for 3 volts, we use two battery. Two battery. So we connect. Okay. Notice reverse biasing, so I have to change the terminals. So you connect the battery accordingly, the positive, negative. So I have a reading on the voltmeter, on the ammeter and the voltmeter accordingly. Now the reading is 0.5 ampere on the ammeter. The corresponding reading on the voltmeter is 1.35. 1.35. Remember, I'm using the downward reading. So 1.3. 1.3 reading from the voltmeter, and you can see the trend. Both are increasing. So I have 1.5 from the ammeter, and I have 1.3 from the voltmeter. 1.5 on the ammeter, 1.3 on the voltmeter. Then I will take the reciprocals respectively. The next one, you change the cell with 2 batteries to 3. So when you change it, you observe what happens in your readings. You have the cell connected accordingly. So it's now three battery, 3 cells, each of 1.5 volts altogether. So I'll be having 4.5 volts. So I have a reading. I have 0.7 ampere on the ammeter, and on voltmeter I have 1.82 1.82 1.82 on the voltmeter, 1.8 on the voltmeter, and 0.7 you record, 1.82 and 0.7, all in 3 decimal placement accordingly. So let me also make room for E here. The one of 1.5, 3.5, 3.0, 4.5, 6, 7.5. These are the electromotive force of the battery used. So we go for 4 batteries. So we change the EMF of the circuit to 4. I'm adding an extra cell here to 4. So we have the trend is that as the current is increasing, the voltage is also increasing. So we have 0.95 ampere, and we have on the voltmeter 2.25 0.95 on the ampere, 2.25 on the voltmeter, 2.25 and 0.95. You can see the trend, and the voltage is increasing, the current is increasing with respect to the EMF of the cell. Of course, if you remember that E equals I into R plus R, you can see the relationship. The current has a direct relationship with the electromotive force. Current has a direct relationship with the electromotive force. Then remember, voltage directly proportional to the current. So as voltage is increasing, current is increasing, provided the resistance is constant. And here in our connection, we have kept the resistor 2 ohms constant throughout the process. So this practical is trying to verify Ohm's law. So this is a practical for verification of Ohm's law. So the last one we want to do is when the cell has an EMF of 7.5, that is 5 cells now, 1, 2, 3, 4. So we add 2, making it 5 altogether. You can use a battery rack so that you can capture everything at a glance. So we connect appropriately. Connect appropriately. To make that connection, we have a bigger reading, ammeter reading 1.1. Remember, I'm using downward reading. Then voltmeter reading 2.7. 2.7 for voltmeter. So you can see ammeter reading 1.1. That is the last with a cell of 5. That is 1.5 volt times 5, 6, 7.5 volts. So cell of EMF 7.5. So we have our reading 1.1 and 2.7. 2.7 for the voltmeter, 1.1 for the ammeter. So remember, we are plotting a graph of voltage inverse against current inverse. So how do you find voltage inverse? 1 over 1.3. Write your answer in 3 decimal placement. All your readings should be in 3 decimal places. So that's the nature of the reading and the table. Did the solution of the BII. Total resistance equals parallel resistance, that is resistors in parallel, the total plus the one in series. So the one is parallel, R and R, plus the one in series. Find the LCM, 2 over R. 2 over R plus 2 over 1, equate it to 4. That means the R is 1 ohm. So that is my own prediction, and I believe it will be a very great help to you. Remember once again to subscribe to my YouTube handle at Peter Amechi 2028. Thank you for your time, and God bless you.